All right, let me cover the solution to this kind of Khan Academy problem. In these problems, they want us to round the answer to the nearest tenth. So we're going to do it without radicals in the answer. But the problem is to find that diagonal that travels from the front lower left corner to the back upper right corner. And they label that D. I'm going to pull that right triangle out. So I am pulling out this right triangle. And you can see I have to draw an extra piece in here. Here's the diagonal along the bottom. That's where D resides. And this is going to be 5. And I don't know this. I'm just going to call it X. If I knew X, I could use the Pythagorean theorem to solve for D. Well, X is part of another right triangle. It is part of the right triangle that lays on the bottom of this rectangular prism. So I'll pull this one out. And it is going to have a leg of 2 and a leg of 8. And this is the same X. The hypotenuse of this triangle that lays on the bottom is the leg of the triangle that I need so that I can solve for D. So here we go. 2 squared plus 8 squared equals X squared. 4 plus 64 equals X squared. 68 equals X squared. X equals the square root of 68. Now, I am going to leave this in radical form because I know that when I replace this in here and use the Pythagorean theorem again, I am going to end up squaring the square root of 68, giving me just 68. So we'll go ahead and this is the square root of 68. Now I can use leg squared plus leg squared equals hypotenuse squared. So I can do square root of 68 squared plus 5 squared equals D squared. Square root of 68 squared is 68. 5 squared is 25 equals D squared. It looks like I have 68, 25, 78, 88. Looks like I have 93 equals D squared. D is going to be equal to the square root of 93. Now, I know that, and you can't see it here, I can show it to you. It would like be us to round the answer to the nearest tenth. So I will go ahead and take the square root of 93. Square root of 93. 9.643, 9.6436. 9.6436 approximately. So rounding to the nearest tenth gives me 9.6. So a two-part problem. I had to find the hypotenuse of a right triangle that was laying on the base so that I could use that value as the leg for the triangle that I was going to use to find the diagonal. I hope that helps. Please email me and let me know if this needs any further clarification. Thanks.